Fuel is any substance that sustains combustion. Fuel is one of the 4 components needed for fire to exist. Fire cannot start or continue if there isn't any material to burn. Under standard temperature and pressure conditions, fuels can exist as a solid, liquid, or gas. A solid fuel has a fixed shape and volume. The molecules do not move unless acted upon by heat or a chemical reaction. An example is a piece of wood or a piece of furniture. A liquid fuel can take the shape of its container. The chemical bonds and spacing between molecules tend to be weaker and more distant than solids. An example would be gasoline or alcohol. A gas is a substance with no shape or volume of its own. It will expand to take the container's shape and volume. An example would be propane or air. Fuels can change states of matter if acted upon by heat, which is important when it comes to fire. To support flaming combustion, fuels must be in a gaseous state. Here we see a natural gas fire pit. As we turn the natural gas on, the gas mixes with oxygen in the air and is lit with a lighter, the ignition source. The flaming air-fuel mixture can sustain combustion. Since the gaseous fuel readily mixes with oxygen in the air, no other processes are needed to sustain flaming combustion. Next, we see a gasoline fire. As you can see, there is a space between the liquid and the flame because the liquid gasoline cannot burn. The gasoline must undergo vaporization or a change from a liquid to a gas to sustain combustion. Gasoline vaporizes at ambient temperatures, so you do not need to add heat for gasoline to vaporize. For some liquids, such as diesel fuel, vaporization requires the addition of heat. Lastly, we see a piece of wood burning. At first glance, it may look like the wood is on fire and sustaining combustion, but that is not really the case. If you look closely, you will see a gap between the wood and the flames. Like liquid fuels, solid fuels cannot mix with air and burn. These solid fuels must undergo pyrolysis, which breaks them down into simpler compounds. This produces fuel gases which can mix with oxygen in the air and burn when the correct air-fuel mixture is ignited. On the fire ground, you will encounter many different types of fuels. Understanding how these fuels react when exposed to heat gives insight into how fires ignite and spread.